So this is a simple geometry problem. We can draw the triangle right here, and the shortest side is 15, though the middle side is 20, and the longest side, or the hypotenuse, is 25. And the reason why I said it was the hypotenuse is because we know that this is a right triangle. The reason why, for those of you who don't know, a famous Pythagorean triple is a 3, 4, 5. Is 3, 4, 5. And 3, 4, 5 is a type of right triangle. And the reason why I know that the triangle we have in the actual problem is a right triangle is because it's a direct scale factor. So you can just multiply each of the side lengths by 5, and we would just have a bigger scale, bigger scale of this basic 3, 4, 5 triangle. It's just larger, but it has the same side lengths, same scale factor for the side lengths. And another way to find out if it's actually a right triangle is by using Pythagorean. So 15 squared plus 20 squared is equal to 25 squared. Or a squared plus b squared is equal to c squared. C being the hypotenuse. Okay, so since we know it's a right triangle, it makes our lives much simpler. So first we want to find the area. So 20 times 15 divided by 2 is equal to 150. And it's asking, find the triangle's shortest altitude. Well, we already know two altitudes. Number one, the first altitude being 15, the first altitude being 20. So altitude 1 being 20. And for those of you who don't know what altitude is basically a fancy word of saying height. So the height of the triangle, or the height of the triangle, or like anything perpendicular, the base, something a line perpendicular to the base. So we can see that altitude 1 is equal to 20. Well, the other altitude we have is altitude 2 is 15. And the reason why I know that is because if we just flip it over into this triangle, 15, 20, and 25 is the same triangle. 15 is also altitude because it is perpendicular. The line of 15 is perpendicular to the base, which is 20. So that's altitude 2. And I want to make sure that you don't choose E, because there's another altitude that we have to play in, we have to calculate. So it's altitude 3. So each triangle will have 3 altitudes. I want you to memorize that too. Altitude 3 is equal to what? So we know that the two bases can be 20 and 15, but another base can be 25. And as you see here, this is the altitude, line X. X is the distance from the vertex, one of the vertexes, to the 25 side. And as you can see here, we can quickly find X. So 25 times X, because it is also a right angle, and altitude multiplied by the base, which in this case is 25, the altitude being X, is equal, divided by 2 is equal to 150, which is the area, because it's the same area of the original of the triangle. Okay, as you see here, we have 25x is equal to 300, and x is equal to 300 divided by 25, which is just 12. X is equal to 12. So that is the shortest altitude between 20, 15, and 12. The shortest altitude is 12. So altitude 3 is 12, and that is the answer, B.